Alright? Check your learning number 3. A lead ore, galena, consisting mainly of lead 2 sulfide or plumbous sulfide, is the principal source of lead. To obtain the lead, the ore is first heated in the air to form kanisha lead oxide with a given equation. So it is an exothermic reaction. Mo release siya og 415.4 kilojoules of heat. So by the way, there is a 2 here. That's plumbous oxide. The oxide is then reduced to metal with carbon. So gikan aning oxide nga PbO, lead to oxide, to reacting with carbon, ma-reduce siya to metal only. So lead na lang habilin. And this reaction is endothermic. Mo-absorb siya 108.5 kilojoules of heat. Now we are to calculate the enthalpy change for the reaction of 1 mole of lead 2 sulfide with oxygen and carbon, forming lead, sulfur dioxide, and carbon monoxide. So this time, ang atong reactants kay si lead sulfide, si oxygen, ug si carbon. And when these three react, mo produce na sila og lead, metal, carbon monoxide, and sulfur dioxide. So, ang atong i-predict ani, is this reaction endothermic or exothermic? Positive ba ang delta H or negative ang delta H? Will it absorb heat or will it release heat kung mahappen ni siya nga reaction? So, let's look at the reactants. Ang nasa reactant sa final na equation kay lead sulfide, of course, we have to base it here in equation A and B. So, si lead sulfide in equation A is on the reactant side. And then, we have carbon also on the reactant side of equation B. And then we have, on the product side, we have lead na diri in equation B, which is on the products nga side. Carbon monoxide is on the product side as well. And sulfur dioxide is on the product side as well. And we also have oxygen on the reactant side. Okay, so same position na sila. Ang tanan nga naa sa reactant side diri sa final ng equation is naapod diri sa reactant side sa given two equations, and tanan diri naa sa products nga side sa final nga equation is also on the product side of the two given equations. And you have to take note also, 1 ang coefficient ni lead sulfide here, same sila. 1 ang coefficient ni carbon, same. 3/2 ang coefficient ni oxygen, so same sila. For the products, we have lead 1 here, so 1 po dire. Carbon monoxide, same. Sulfur dioxide, same. So what are we going to do? We will just add the 2 directly. And upon adding the 2, dire na lang na to i-add diretso. When we add the 2 equations, inig-add sa 2 nga equations, kay same naman ang positioning. So, ang makancel lang ani kay ang kaning lead oxide. And when you cancel lead oxide, so kani silang tanan nga nasa reactant, mura sad ni siya. And kani siyang tanan naa sa products, kay mausad ni siyang nasa products. So, adding them, we will also add the change in enthalpies. And our change in enthalpy, therefore, is negative 415.4 plus 108.5. And our answer is negative 306.9 kilojoules. So we can see that the reaction is exothermic. So in lead sulfide, when 1 mole lead sulfide is reacted with oxygen and carbon, mo produce siya og lead, carbon monoxide, and sulfur dioxide, and will release 306.9 kilojoules of energy. Another check your learning number 4, is all about hydrazine. So hydrazine, with the formula N2H4, has been used as a rocket fuel because its reaction with oxygen is extremely exothermic. So, kung mayroon siya extremely exothermic, meaning dako kayo nga amount sa energy ang iyahang ma-release. And this is the equation, thermochemical equation for the combustion of hydrazine. So, it will release 534 kilojoules of heat.
The enthalpy change for the vaporization of water, meaning gikan sa vaporize, meaning gikan sa liquid padung sa gas, no? So, is here given in the equation is 40.7 kilojoules, meaning in turn ni liquid to gas, mo-absorb siya og heat. So, muna siyang 40.7 kilojoules. So, we are to calculate the enthalpy change that would result if the water were produced in liquid rather than in the gaseous form. Meaning, tanawa diri sa equation A, ang water na na-produce, no, is gas. So, instead of gas ni siya, what if liquid? Pila may change in enthalpy here? Would it still be 534 or would it be greater than that or less than that? So, muna ato ang solvon. So, this is the equation. So, let's solve. Our target equation is, let's write the target equation. It is hydrazine, N2H4, liquid, plus oxygen, producing N2, plus 2H2O, liquid. And we are trying to solve for the change in enthalpy. Okay? Now, the given, ang atong given, equation A, is N2H4 na liquid plus O2 nga gas producing N2 nga gas, that's nitrogen gas, plus 2H2O, but take note that this is gas. And delta H here is equal to negative 534 kilojoules. For equation B, it's the vaporization of water. So, liquid turning to gas. And the change in enthalpy here, ma-absorb siya og heat, it's 40.7 kilojoules. So, if you notice atong target na equation, ito ni highlight atong target na equation. Ang na-change ra gyud, diba? Kay ingon man siya nga instead of gas, kani, kay dapat liquid na. So, dapat kaning gas diri in equation A should be cancelled out. And asa man na nato magikan nga ma-cancel out? Kaning sa equation B. So, para ma-liquid ni siya sa atong target na equation, and para ma-cancel ni si gas, so what we're going to do with equation B is to reverse it. But take note nga sa equation B, 1 rapod ang iyahang coefficients. Unya, 2 man ni siya. So, dapat i-multiply sa nato siya by 2. So, what we're gonna do with equation B is to reverse and multiply by 2. So, this will become H2O nga gas padulong sa H2O nga liquid, no? And so, then, delta H would be, may mo siyang negative 40.7 kilojoules. And then, we multiply. So, this is the reverse. And then we multiply by 2. So, times 2. So, 2H2O gas, 2H2O liquid. So, pila naman yung delta H? So, 40.7 times 2, that would give us negative 81.4 kilojoules. So, next is, ang atong buhaton is, tanaw-tan ni equation A, og, kaning na reverse na. Og na multiply by 2. So, unsa may common sa duha, kaning equation. Unsay common ani nilang duha? So what we see is ang H2O nga gas. So kani si H2O nga gas ug kani si H2O nga gas kay ma-cancel. So unsay nahabilin? N2H4 plus O2 gas. Take note ato lang gikopya. Wa na may nahabilin diri. And then producing N2 nga gas plus duha ka moles nga H2O nga liquid. So unsa atong gibuhat sa duha kang equation? Ato ra silang gi-add. And because we added them, then we are also going to add the two enthalpy changes. So, negative 534 kilojoules plus negative 81.4 kilojoules. And that is a total of, that would give us a total of negative 615.4 kilojoules. So, if ang ma-produce kay liquid instead of gas, then a greater amount of energy is released. So take note, na kani siyang final nga equation na to is already the same with the target nga equation. Check your learning number 5. So another one for Hess law. Given the following thermochemical equations, so we have 3 here equations, and these are all exothermic, so they all release heat. Calculate the enthalpy change for the decomposition of 1 mole of acetylene to its elements in their stable state at 25 degrees Celsius and 1 atm atmosphere. So that's pressure. So, take note to its elements ko no. To decompose meaning mabuwag siya. When we say decompose of acetylene, so we have C2H2. That's gas. Ug mabuwag siya sa iyang elements. So, sa may elements nga ni-compose ni acetylene, it's carbon, and hydrogen. But take note that this hydrogen, can you see hydrogen? It's diatomic, H2, and that's gaseous. And hinumdumi class nga when you write the equation, dapat balance po gid na siya, no? So H2, H2 diri, C2 diri, so dapat 2 ang carbon. So we put a coefficient of 2 here. And we are looking for delta H. Okay. So because this is our target nga equation. So anhin na sa tabase sa atong given nga 3 thermochemical nga equations. So in equation A, we have acetylene here on the left side. So let's highlight that, which is also here on the left side of the target nga equation. Alright? So in equation B, we have carbon here. But in our target nga equation, si carbon kay naa sa products nga side, unya 2 ang iyang coefficient. So what are we going to do with equation B? We are going to reverse it and multiply by 2. Okay, reverse and multiply by 2. And then so, ato din na siyang shadean o blue. Okay? And for hydrogen, it's here on the products nga side. But in equation C, we have hydrogen on the reactant side. So 1 raman ang iyang coefficient. So all we have to do for equation C is to reverse. So muna siya to buhaton. So to answer, so as is ang equation A, let me write that again. Equation A is, okay, let's write that here sa ubos. Okay, C2H2, that's gas, plus 5 halves oxygen, that's also gas, producing 2 CO2 gas, plus H2O liquid. And the change in enthalpy here is negative 1299.5 kilojoules. And then, sa tibuhatan sa B, for B, we are going to reverse of B. So, I want you to look at your copies there. Inig-reverse ni B, so may mahitabo. Mahimo to siyang CO2. I want you to look at your copies kung sa given. So, this is now CO2 gas producing carbon plus oxygen gas. So, kay reverse man siya, na-reverse po ang iyahang change in enthalpy from negative, mahimo na siyang positive 393.5 kilojoules. After reversing, multiply by 2. So, in multiplying by 2, mahimo siyang 2 CO2 gas, 2 ka carbon, plus 2 ka oxygen gas. And delta H should also be multiplied by 2. So, 393.5 times 2, that would give us a value of
787 kilojoules. And that's what we are going to add here. I-add na nato siya diri. So let's write 2 CO2 gas. That's 2 carbon plus 2 oxygen. And then delta H is equal to negative, or that's positive, 787 kilojoules. For C, we are going to simply reverse. Let's use the red pen. So we reverse C. I want you again to look at your copies. So mahimo ninyo yung H2OL producing hydrogen gas plus 1/2 oxygen gas. And that would give us an answer, or that would give us a delta H of, nabaliktad raman. So, nahimo siyang positive 285.8 kilojoules, and that's what we're going to add here sa ato equation. So, H2OL, H2 gas plus 1/2 oxygen gas. And delta H is equal to 285.8 kilojoules. And so, adding, so we add, and we also add these here. Add na nato. So, ang C2H2, siya raman dyan na isa din ha. So, we are simply going to copy that here sa ubos. C2H2 gas. Si carbon dioxide here on the left side. And we have CO2 here on the left side as well. So, makancel na siya nato. Let's cancel that. And then si water. We have water here and another water here. So, we can also cancel that one. Okay. naatay oxygen din eh. So, pila man ni? Duha og to nga. 2 and 1/2. When you add them, 2.5 is 5 halves, right? And that's equal to 5 halves here on the left side. So, we can cancel oxygen. So, meaning sa reactant side, ang mahabilin si C2H2 ragyod acetylene. And on the product side, ang mahabilin kay duha ka carbon plus hydrogen nga gas. So, as you can see, this is already the decomposition into its elements, no? C2H2, so we have the elements carbon and hydrogen, and take note that it's already balanced. So, kay gi-add naman na nato sila, then we are also going to add the change in enthalpy. So, delta H is equal to negative 1299.5 plus 787 plus 285.8, and that would give us an answer of negative 226.7 kilojoules. So, as you can see, the reaction is exothermic. Mo-release siya og heat, inig-decompose niya into its elements at 25 degrees Celsius and 1 atmosphere nga pressure.